In this video, we'll be investigating the mechanics behind a reversible laminar flow. If a fluid moves in smooth sheets and in predictable paths, the flow is described as laminar. If the flow causes the fluid to move unpredictably, producing vortices and crossing paths, we call this turbulence. The Reynolds number is a ratio of the inertial and viscous forces, or the ratio of destabilizing to stabilizing forces. Thus, Reynolds number describes the quality of the flow. Greater destabilization in the net forces results in turbulence. Contrastingly, laminar flow systems have very predictable fluid movement. So predictable, in fact, that we can reverse the mixing that happens utilizing laminar flow. Using this reversible mixer developed by Harvard, we can model and put into practice reversible mixing in viscous fluids. The mixer consists of an inner cylinder, which rotates, and an external stationary cylinder. This produces a flow field. As long as the velocity is slow enough, the device will produce laminar flow in corn syrup and turbulent flow in water. We filled up the reversible mixer with 100% corn syrup, which is a very viscous fluid, and have put in 3 lines of different food coloring so we can see how the fluid layers move. As you can see, the fluid layers have moved out in sheets around the inner cylinder. When we turn the reversible mixer the other way, the sheets of color have unmixed back to their original positions. This is because the laminar flow exactly undoes the laminar mixing, since the paths of the fluid all remain separate. We've now filled our mixer with a solution of 25% water and 75% corn syrup to lower the viscosity of the fluid. This will decrease the stabilizing forces in the reversible mixer and make the flow more turbulent. As you can see, while the colors did return to their original space, the bands are more stretched out and blurrier than when we started. This is due to the mingling of fluid paths during the mixing and unmixing process. Now we are going to try and run the experiment with all water. As you can see, the fluid is so inviscid that the force of injecting the dye into the water already causes irreversible mixing. Even still, we tried out the device. As you can see, the turning of the reversible mixer has caused a turbulent flow to occur in the device, thus creating a permanently mixed solution. You can pause the video here to take a deeper look at the calculations for Reynolds number for the 3 different conditions of mixing. Clearly, viscosity has a major effect on the quality of flow in a system. As we decrease the viscosity of the fluid, we see more chaotic mixing, which can't be undone like simple laminar mixing. By decreasing viscosity, the same velocity can have drastically different effects on the mixing and unmixing of a fluid. So next time you try and reversibly mix a fluid, remember, thicker is always better.